Alright, so parts have arrived. Here's what I came up with, because we have to deal with what we can buy on the market these days. So for the 1125 at 20 watts, we're going to use a 1500 ohm that I have in there now, or I have one that looks just like one of these, in parallel with a 4.7K 5 watt. The 20 watt is going to be one of these guys, so we'll put it on the existing shaft. I think it's going to be two of these side by side, I believe, are just about exactly the same length as that. So that's my overall plan. The 4.7K 5 watt will be much smaller. We'll tack it, and it'll be supported by this guy. For the 650 at 20 watts, I believe I picked up a 680, similar packaging style. So I got a 650. So we go with a 650 at 20 watts, paralleled with a 10K at 2 watts. Really, the 650 is probably close enough to 610, which is our target, but yeah, we can throw a little 10K in there to get even closer. And here's what it looks like. The only downside is these aren't the type where the lugs just come straight out this side with a big eyelet. They have leads, but we'll bend them, we'll manipulate them. Obviously we can't have two of these butting up and then having these short together, although because these do not connect together where they butt up against each other. We have four separate distinct leads coming out here, and I'll dig up a mica or ceramic insulating disc to put between the ends just to make sure they don't make contact. So that takes care of this guy. That's actually the easier one. The can dome, not so easy. We're going to have to drill this out and remove this whole assembly. So then what do we put into place? We just going to have wires hanging here. Well, this is what we got to deal with. 8.2K at 5 watt, 33 ohm at 2 watt, and 100 ohm at 3 watt. Now these two guys, that small size, they're just going to be regular axial-leaded resistors. What am I going to mount them to? Well, because if we take this out, we have nothing. We could mount some terminal strips. But what I'm going to do, what I propose doing, is use these aluminum housed type resistors. So I actually got 25 watt, 8200 ohm. Vastly more than we need, but when you go to the larger sizes, you get chassis mounting options. You can always go larger in wattage, not a problem. In fact, it's actually beneficial. So we're going to use this for the 8200. It has mounting holes, so we're going to have to drill a couple little holes in here. Ideally, I'll find some self-tapping screws. Now, these holes are pretty small. I think they're 3mm. I think a number 3 American screw size thread might just fit. That's smaller than I can find in my local hardware store, so I may have to paw through what I have or order some specialty screws to mount that. But the idea being is we're going to mount one of these guys. That takes care of the 82. And then I got a 12.5 watt for the 100 ohm. That was the smallest wattage I could find. It was chassis mount. We only need 3 watts, but we're going to go with 12.5 because it's also one of these. A little smaller, but same type of deal. Now for the final one, for the 33, I'm going to mount these two guys to the metal, and then I can string the 33 between those lugs because they do all connect in series. So remove this. Drill 4 tiny holes, find 4 tiny screws, mount these two guys down, and bridge it with that third resistor. And up here we're going to use 2 resistors that look just like these, slide them down that existing screw. So there's a threaded screw that runs this entire length. And we'll insulate between the butted up ends. In fact, yeah, we can reuse, there are insulating washers at the end, so we'll reuse those. So we just need to dig up one for the middle and wire it all up. That should take care of that. There we go. And I need to disconnect the wires going to it. And we'll see about mounting the new resistors in here. I'll have to drill some tiny holes. Still trying to find some tiny screws to match up with those. I may have to enlarge the holes on them a little bit so I can use number 4 screws. I just simply clipped the leads off, got that out of the way, and then since everything's disconnected, I just took the 4 screws off and took this whole thing out. So those of you, whoever wanted to know what it looked like with that unmounted, there you go. And a bunch of insulated wires sticking out. course I want to get rid of all the bits of metal from the drilling operation. And while I got this out, I will clean around this area. It'll also make it a lot easier to mount and do work down in here with that out of the way. So I'll drill my tiny holes, mount those 2 aluminum house resistors, and put the other one in the middle, and work on mounting these better. The original being much fatter, the mica washers that were used for this guy don't quite work so well on the smaller one. Alright, a few things. One, I gave this area a wipe down with CLR. Does a fantastic job of cleaning this type of chassis. Underneath this weird brownish yellowish crud, the metal was in really good condition. No rust at the top of the transformer. Alright, now as for this, I just had to enlarge the holes a touch, and I've got a number 4 screw to fit through on this guy. And then I installed a sill pad, this flexible conductive pad material, thermal interface product. Anyways, it's better than thermal grease, not as messy, but does a pretty darn good job. Not that these are, everything is over spec'd, so I don't expect these to get all that hot. Anyways, and then I'll put a 33 ohm resistor between these two, mount that guy up there, get this remounted, rehook all the wires up, and that should work out just fine. Actually better than the original. Alrighty, there we go, all wired back in. Now let's make sure it still works. Yep, still working. So, next up, let's actually try feeding a signal into this set and see if we can get something going through it. I powered the set back up and tried injecting a signal for the first time, and with those 3 dead 6AG5s in there that I tested earlier, that's virtually zero emission. I got nothing. I have a dwindling stock of new old stock 6AG5s, RCA branded. Pop 3 of them in there. I'm going to try to keep it all RCA tubes if I can. And with a bit of fiddling, we got something. That's supposed to be a circle with a box around it and an X through it, or a cross through it. And as you hear from the speaker, we still have some pretty bad hum. I replaced almost all the electrolytics. We just have one left. I'm hoping that takes care of it. Otherwise, well, we shall see. Now, then, of course, there are still some paper caps to do. Did a little bit of work on some of the sound caps, and well, obviously that didn't help much. And I still haven't done the vertical. I think the vertical is running at twice the frequency it should be, or something like that. And that hum that we're hearing in the sound is clearly getting into the video, or the horizontal deflection circuit, because it's really bad. So we got more work to do. I'll get back to it. I'll pick up with replacing more caps. Couple things, and getting back down here to do a little bit of recapping. In particular, get the last electrolytic. Now this one's a little bit unusual in the values of it. The other caps are like 20, 40, 60 microfarad at 400, 450 volts, but these 250 microfarad 10 volts, 1000 microfarad 6 volts. Crazy for a tube TV, right? Well, these are used for the horizontal and vertical centering pots. Those pots apply a slight DC bias to the yoke windings, and you really need to filter that well, because a little bit of ripple getting into the yoke can produce a pronounced effect on the image. You don't want it wavering at all. But you only need a tiny amount of current, so it's just or I should say, the yoke windings are fairly low DC resistance, so you don't need a whole lot of DC voltage to get enough current going through them to offset the picture a little bit. So low voltage, really high capacitance. That's going to be a little bit concerned though, because If this is bad, that wouldn't be producing hum in the audio. It's a different circuit. I don't think it would be affecting the picture as profoundly as what we're seeing. I don't know. Well, there are some paper caps left, but diminishing few. But there is one other one I wanted to point out right next to where the electrolytic goes. This guy, it's a replacement. I never soldered it. Other end is just floating there loose in the eyelet. So I'll replace these caps and then power it up again and see if we're getting any progress on eliminating the hum. There is another possibility, which is that I made a mistake somewhere with replacing the other filter caps, so I can get a scope on the B plus and see if there's excessive ripple coming through some electrolytic caps I put in here, and pretty quickly found a problem on these three guys down here. Remember, the negatives on these filter caps do not go to the chassis. The chassis is not the grounding point for these caps. These bare bus wires are. Now with these adapter caps, there's a ring that goes around the outside, and that connects all the negative leads of the caps together. That's going to these bare bus wires. That's how it was wired up originally. So this negative is going to this negative, then it goes over to this, and then all points all over the chassis. But this guy, there's one bare wire going over this 2-pin, and that's going to a resistor, and that's it. It's supposed to have another wire going between these two, but not the chassis. So this cap, these three caps, are effectively out of the circuit. What is that? What are they? It's C128. So it's one of the caps right after the rectifier and between the negative rail and ground. So the positive lead on one of these caps goes to ground. The negative on all these caps goes to the center tap of the power transformer. And the final one is a cathode bypass cap on the vertical output tube. So I suspect reconnecting that cap, those three caps, is going to have quite an impact. I'm just going to use an alligator clip lead to just clip it back in temporarily to see what effect it has before I make the permanent connection. Alright, here it is with those caps still out of circuit. Then while it's turned on, I'll clip them in. So we hear the hum right away. And we get that horrible black bar there. Alright, I'm going to clip into the circuit now. Boy, that made quite a difference, didn't it? So, hum's gone, black bar's gone. More height out of it, too. There's so many controls in the back of this set. I think that might be height or linearity. Let's see about reception. That's brightness. Let's turn off the gain. Ah, there it is. Hey. Amazing what difference a little capacitance makes. Alright, controls. This is height. Linear. Okay, here's linearity. Ooh, linearity control does absolutely nothing. If that control's bad, this is height. So height works. But linearity is not doing its thing. Vertical hold's a little twitchy too. Huh, I don't know what's up with the linearity control. Squeeze back through and reduce controls. Yeah, it sure says vertical linearity. It does absolutely nothing. Regardless, it's a heck of an improvement. Let's see about some programming. It's getting better. It's not going to focus too well with this little baby test CRT. I'm just focusing on the contrast. No pun intended there. Yeah, aside from the vertical linearity, it's looking promising. Let's see, do we have sound? No, we do not. Ah, there we do. Ooh. Fun thing with these really early sets, you can have the sound and video really out of sync with each other. So in other words, when we have the best sound, we do not have the best picture. I'm working topside now. I just took the high voltage box off, which leaves a few of these parts unsupported, so you want to be careful when you do that. But also really want to get in here and clean and get all these dust bunnies out, which can will reduce the chance of any corona or arc over, and this generally gives me a chance to clean and examine everything. And also that high voltage box was kind of rusty, so I threw that in some evapor rust. I'm really getting down in here and cleaning it well with that cover removed, and believe it or not, this high voltage lead is actually red underneath all that crud. Using denatured alcohol to remove the gunk. Hard to believe that's the same wire, but yeah, it cleaned up very nicely. Also put a new grommet on this for the little holder here. This old one is rock hard, and that just leaves reattaching the little high voltage thing. Thread the wire through, heat up the end, and push the end of the bare wire into the molten solder. Also got it all cleaned up inside here. Got some new tubes in place, and I just painted this nice flat black. So when this arrived, we were missing the other half of this high voltage cage. Well, I'm going to take it out of one of my sets with the hope that somewhere down the road I can get one from someone else. I'm pretty sure I saw one at the TV convention in May. Didn't think that I might actually need it, so I didn't take it, but there'll be another swap meet in October. Maybe I can grab one or two when I'm there. Something else I'm doing is replacing those weak tubes. Seems to work alright with them in it, but they test really bad, so out they go. So I believe there was one 6J6, a 6AG5, and a couple 6SN7s. Now I think it's fitting that I'm using rather late production RCA branded 6SN7s, because it sort of represents all the years and all the rounds of repair that this set has had, so that's what I'm going with. So we have a mix of some, I believe, are the original tubes that came with this, and then multiple passes of replacement RCA tubes over the years. Alrighty, we are getting there. I dug out a high voltage cage cover from one of my sets so we can wrap this up. Got the set fired up, test pattern generator going, and I'm going through all the adjustments, and there are quite a few on this set. We have vertical centering, horizontal centering, vertical height, vertical linearity, horizontal drive, horizontal linearity, horizontal width, and horizontal frequency lock, in addition to the controls on the front. for brightness and contrast and horizontal hold and vertical hold and volume and fine tuning and channel. So right now I'm working on getting all the linearity and the centering squared away. I took the focus coil off and moved it to the side so it won't interfere with this test CRT, which does not need it. Likewise, the ion trap magnet is down below. And curious thing, the set that I took this off of is also a 721 TS, so it must be a little bit newer because it does not have an electromagnetic ion trap magnet. It just uses the more common permanent magnet type that just snaps on. So just in case you're working on one of these yourself and you don't have an electromagnetic ion trap, not all of them did. Not all of them did. So far, got a little bit of work to do. The vertical linearity is off a little bit. Need a little bit more width, but really good, sharp, clean picture.